Hello guys, welcome back to STEM Trainers. In the previous video, we have seen two questions on forces and friction. So now we know how friction applies, what is coefficient of friction, what is limiting friction, and if net forces in any direction, that is parallel to surface or perpendicular to surface, are zero, then it means it will have no acceleration, etc. etc. So let's today do some pulley questions. So this is our first question. A particle of mass 10 kg is on a horizontal rough surface. The coefficient of friction between A and surface is mu. A is connected to particle B as shown. Given that B hangs at rest, find the range of possible values of mu. Okay. So now, as we did in the previous questions also, first thing that we will do is, once we have our diagram, we will try to write all the forces that we can. So we know that if this system is at rest, so this is mg force. What's the mass of B is 4. So this is 4g. There will be a tension T here. There will be a tension T here. And there will be frictional force acting in the opposite direction to friction like this. And there is mg of A. A is 10 kg. So this is 10g. This will be the normal reaction. So these are all the forces that are acting on the system. So first we draw that. Second thing is, we will see that now it's given that B is at rest. Now obviously if B is at rest, A is also at rest. So we can say that acceleration is 0. So we will consider the forces parallel to the horizontal surface. So this is my horizontal surface and perpendicular to the horizontal surface. So let's first see what happens for A in the horizontal direction. So in the horizontal direction, as net force is 0 because it has no acceleration, so we can say that tension should be equal to frictional force, or you can write tension minus frictional force should be 0, same thing. Now second thing is, in vertical direction, my R will be equal to 10 times G. So this is in vertical direction for A. Now similarly we will do for B. Now for B, we know motion is or forces is only in vertical direction. So we will consider only vertical direction. So for B, in vertical direction, what's happening? So tension will be equal to 4G. That's it. Nothing else is there. Because system is at rest, that is B is at rest. So now we have the value of tension. So this is our first equation, this is our second, let's say this is our third. So from first and third, we can say that my frictional force is equal to 4 times G, right? Because tension is equal to frictional force and tension is equal to 4G. So frictional force is 4G. Now what they are asking is, we have to find the range of possible values of mu. Now we know that at any point of time, my frictional force is always less than or equal to mu r, right? And mu r is the limiting case. So from this I can say that my 4G value should be less than or equal to mu. We have to find R is 10G. So if you cancel the G, so from this we can say that my mu value is greater than or equal to 4 by 10. That is, mu is greater than or equal to 0.4. So that is my answer for the first part. I hope everyone is clear about this. Now this is very important. This is the limiting case, right? Maximum case mu r. And friction is always less than or equal to this value. Okay. Now let's do the B part. When B is replaced by a particle C of mass 7 kg, the system accelerates at 0.8 meter per second square. Find the value of mu. Okay. So now we have changed the system little bit. So let's draw a new diagram. This is my A. So instead of B, now we have a particle C of mass 7 kg. So this will be 7G, this will be my tension, this will be my tension, frictional force will be acting backwards in this direction, frictional force. This is my mg 10g, and this will be my reaction force r. And what else is given is important is this: system accelerates at 0.8 meter per second square. Now obviously if the system accelerates, so obviously the system will, this particle c will go downwards, right? It can't go upwards because there is no upward force, correct? So obviously, let's say this is my acceleration, and a will accelerate in the right direction towards the pulley if system accelerates, because there is no external force, right? So only mg is there. Okay, so let's find out this acceleration. We have to find the value of mu in this. So again, let's analyze for c first. So again, c is moving only in vertical direction, there is no force in horizontal direction. So for in vertical direction, what's happening? Net force downwards is 7g minus tension, and this should be equal to 7 times a, right? Because acceleration is downwards. So what you have to do is you have to see the net force downwards. The net force is equal to mass into acceleration, Newton's law. Now next is for a. So for a, in vertical direction, what's happening? In vertical direction, it's easy, right? R is equal to 10g. In horizontal direction, what's happening? Let's see. So in horizontal direction, tension minus frictional force is equal to mass into acceleration, that is 10 times a. So let's say this is my first equation, this is my, let's say, second equation. So we have to find the value of mu, and we know that if the system accelerates, then frictional force will be maximum, that is mu times r. So let's add them first and second. So if you add first and second, so what will you get? 7g minus t plus t minus fr. Why we are adding is because so that t gets cancelled. So 7g minus this gets cancelled. Friction force is mu times r. R is nothing but 10 times g, which is equal to 17 times a. And we already know the value of a, that is 0.8. Okay, we will substitute here. So from this we are getting is mu is equal to 7g minus 17a divided by 10g. And if you substitute the values, g is 9.81, let's say, and a is 0.8. So you will get approximately mu as 0.561. So that is our answer. I hope it's clear. Okay, let's go for the next question. Now next question is, two blocks A on a horizontal rough surface, okay, with mass 2.5, and B is on smooth inclined plane of mass 1.3 as shown in diagram, okay. When A is released from rest, it accelerates at 0.15 meter per second square towards the pulley. Find the tension and coefficient of friction. Okay, so again, whenever this kind of question comes, the first thing that we do is we make free body diagram. So let's make the diagram. What are the forces? There will be a tension here, and if it accelerates in the towards the pulley, so this is acceleration A, so this will also accelerate parallel to smooth inclined plane downwards, so this acceleration is also A. Frictional force will be acting in backward direction, that is, there is mg. What is the mass of A? A mass is 2.5, so this is 2.5 g. This will be my normal reaction R. Okay, now let's see. So there will be a tension on B like this. Okay, and the one last force is mg. So mg always acts vertically downwards, so this is my mg. Okay, this angle is missing. So let's take this angle to be 45. Actually, it should be given in the diagram. Anyways, so this angle is 45. So let's remove this. Okay. So this is the question. So if this is mg, so what is the weight of this? The weight of this is 1.3 g. So this is 1.3 g. So if this is 1.3 g, okay. So these are all the forces that are acting on this. Next is we will think about in which directions we have to make the forces. So for A, let's analyze for A first. So for A, obviously we will analyze the forces in the direction parallel to the surface and perpendicular to the surface. So let's do this. So in vertical direction, what's happening? In vertical direction, R will be equal to 2.5 g. Right? Because it is not moving in vertical direction. So for horizontal direction, what's happening? In horizontal direction, we have an acceleration to the right. So what is the net force towards right? So tension minus frictional force. Why it is minus is I am telling you again is because friction is in opposite direction to tension. So we need net force in the right direction. So tension minus friction will be equal to 2.5 times A. So this is my equations for A. Now let's analyze for B. So again for B, because B is accelerating parallel to the inclined plane. So we will first find the forces parallel and perpendicular to the inclined plane. So there will be a reaction force R1, let's say, here, perpendicular to the inclined plane. This is mg, then we can say this will be mg cos 45, and this perpendicular component will be 1.3 g sin 45. Right, because this is 45, so this is also 45. So that's why cos sin. Okay. So for B, this perpendicular direction, it doesn't matter because R1 will be equal to 1.3 g sin 45 and we don't need this. So we only need parallel to the inclined plane. So let's do that. So what's the force in this direction? 1.3 g cos 45 degree minus tension will be equal to 1.3 into A. So these are my three equations. Okay, so from these equations, we have to find the tension and coefficient of friction. Okay, and we know that frictional force will be equal to mu r. Okay, so let's first, we know the value of acceleration also 0.15 meter per second square. So let's add this, let's take this as first equation. Let's take this as second equation. Let's add them. Why add? Because when you add, tension will get cancelled, right? So if you add first and second, so what you will get? 1.3 g cos of 45 degree minus frictional force, tension will get cancelled, is equal to, this will be 3.8 times acceleration. Okay, and frictional force is mu r. So let's substitute the values. So we will get 1.3 g cos 45 degree minus mu into r, mu into 2.5 g equals 3.8 into acceleration. And we know acceleration is 0.5 meter per second square. So this is 0.15. So let's find the value of mu from this. So mu will be equal to 1.3 g cos 45 degree minus 3.8 into 0.15 divided by 2.5 g. And when we substitute value of g, so it will come out to be 0.34 or 0.344. So up to two significant figures. So we are getting the answer as 0.34. So this is my mu value. Now once I have mu, or I can directly use the equation 2. In equation 2 directly I can use 1.3 g cos of 45 degree minus tension is equal to 1.3 into acceleration A, that is 0.15. So from this I will get my tension value as 8.82 newtons. So this is my answer. So this is my tension and coefficient of friction. So I hope you understand this. So the only thing is, again and again we are doing the same thing. We are drawing all the forces. Then we will see in which direction we will need to make the component of forces. Then third thing we see is if there is some acceleration, net force will be equal to mass into acceleration. If system is not moving in that direction, then we will say that net force is 0, or you can say that sum of all the net forces will be 0. And that's all. And friction is always, just remember, friction is always mu times r when system is moving. Okay, I hope if you understand these basic concepts, then I think you can solve each and every question. Okay, thanks for watching.